Hi guys, welcome to chapter 3.3, Simple Applications of Trigonometry. Okay, so for this chapter, we will be learning about the angle of elevation and the angle of depression. To make things, to basically put things in layman terms, the angle of elevation is measured positively upwards from the horizontal. So meaning to say, if this is my horizontal here, if I were to go upwards, okay, the angle that I make with the horizontal is just known as the angle of elevation. On the other hand, if I were to measure downwards, okay, the angle that I make with the horizontal, in this case over here, is called the angle of depression. Okay, so let's look at an example to make things clearer. Let's just read the example very carefully. A point 10 meters away from the base of a flagpole, okay, from the point 10 meters away from the base of the flagpole, the angle of elevation of the top of the flagpole is 36 degrees. Find the height of the flagpole. Okay, so just reading this alone cannot help you understand much. What you need to do now is to draw a simple diagram. Okay, so you have a flagpole. Okay, so this is my flagpole. Draw a nicer one. Okay, so this is my flagpole. Okay, the point that I'm looking at is 10 meters away from the base of the flagpole. So this is the base of the flagpole. Okay, and since the point is 10 meters away, this distance is 10 meters. Okay, the angle of elevation of the top is 36 degrees. So what does this mean? Remember, the angle of elevation is measured positively upwards from the horizontal. So in this case, this line is my horizontal, and if I were to measure an angle, okay, positively upwards, okay, from here to here, this will be then known as my angle of elevation. So this angle over here is my angle of elevation. Okay, so to put things in a neater way, I will draw a separate triangle to represent what I just shown. Okay, so this is a right angle. This is my angle of elevation. Okay, this is 10 meters. Okay, so question says find the height of the flagpole. Okay, and this is 36 degrees. Okay, find the height of the flagpole. So this is what we're looking for. Okay, let's just call this unknown x. Okay, so this is what we're looking for. So remember in the previous chapter, we have three ratios: sine, cosine, and tangent. Okay, so with respect to 36 degrees, this is my opposite, this is my adjacent, and this is my hypotenuse. Okay, so we're given the opposite and the adjacent. Okay, so we should be using the tangent function, okay, because the tangent function is given as the opposite over the adjacent. Okay, so in this case, tangent 36 degrees will be the opposite, which is x, over the adjacent, which is 10. Okay, so my x, which is the height of the flagpole, is just 10 times tangent 36 degrees. And if I were to press this in your calculator and I round it off, I will just get 7.27 meters. Okay, and that's the answer. Okay, so the height of the flagpole is just 7.27 meters. Okay, moving on to the next example. A girl is sitting 50 meters away from the stage of a concert. If she is 10 meters below the level of the stage, at what angle of depression is she watching the concert? Okay, so let's just draw an imaginary stage over here. So this is my stage. Okay, and I have a girl sitting at the bottom of the stage. So the girl is over here. I'll just represent the girl with G. Okay, so how far is she from the stage? Okay, if we look carefully at the question, she's seated 50 meters away from the stage of the concert. Okay, so this distance here is actually 50 meters. Okay, And the next part of the question says that she's 10 meters below the level of the stage. So she's 10 meters below the level of the stage. Okay. Okay. So where exactly is my angle of depression? Where exactly is my angle of depression? Remember, the angle of depression is measured negatively, okay, or rather from the from the bottom of your horizontal. So maybe to make things clearer, I'll just use a different line. Okay, so this is my horizontal, okay, and this is my angle of depression. Okay, it's measured downwards from the horizontal. And if you just stare at this very carefully, okay, what are these angles that we got over here? This angle, the two red angles, are exactly the same, because this is what I would call alternate angles. Okay. Okay, so you realize that the angle of depression, okay, this is the angle of depression. Okay, and this angle is the same as this angle. Okay, so to make things look real neater, I'll draw a separate diagram. So this is my triangle, right angle. This is 10 meters, 50 meters, and this is the angle that I want. Okay, so I'll call the angle of depression theta. So over here, this is theta, and this is also theta. Okay, so let us identify, okay, the opposite, adjacent, and hypotenuse. So with respect to theta, this is my opposite, this is the adjacent, and this is the hypotenuse. Okay, so we will be using the tangent function, because tangent theta will be opposite over adjacent. Okay, so opposite is 10, adjacent is 50. So to find theta, we'll just take tangent inverse of 10 over 50. Press this in your calculator and you will get 11.3 degrees. Okay, hope you understand this example. So just to summarize, okay, for this part of the chapter, the angle of elevation is measured upwards from the horizontal. Over here, this is my angle of the elevation. On the other hand, the angle of depression is measured downwards from the horizontal. So this is my angle of depression. Okay, I'll see you in the next chapter.